All right, let's begin. Exercise 13C, the cosine rule. This is when you use the cosine rule. They tell you in your exercise book, your textbook, they'll say when you have two sides and an included angle are given, and then three sides are given. Really, the way I see it, every time I see a non-right angled triangle, the piece of information that I'm looking for is if I have two lengths, A, B, and an angle that is connected to between them. These are called adjacent sides because adjacent means next to. So if you have a side next to a side and you've got the angle given in between it, okay, and you're required to find the next length, this is definitely a cosine, okay? Whereas a sine, for example, sine rule, if I had A, B, and C, what I'm looking for is when I have an angle corresponding to a length and another angle that I might be given, and I might be trying to find that. So what you can see is it's paired up. So B with a B, C with a C. So length with an angle, length with an angle. So that's different to cosine. Or is cosine? It's when I notice that there's two sides that are adjacent, which is next to each other, okay? And they're given an angle in between it. Or they want you to find the angle, okay? So regardless, as long as I see two sides the same and an angle in between it, most of the time that's a cosine rule, okay? Most of the time. Just because if they're giving you these two sides, if you want to change it to a sine rule, it's likely that the angle has to be here because that's corresponding to this side and that angle corresponds to this length. So this would be a sine rule problem, but as soon as I get this, I know it's cosine. If I change that around and I said B, an angle there, that's a cosine rule. If I want to change this to a sine rule, see how I'm doing it? I'm just playing around with the corresponding, if it's side, angle, that's a sine rule. But when you have C, so if I do this, that's clearly a cosine. C and B are right next to one another, and you've got an angle between those two. It's most like this layout would be a cosine rule. Alternatively, if they give you all three sides. Because obviously if you have all three sides, it doesn't matter which angle you're looking for. If you're looking for this angle, that's two sides and an angle in between, it's cosine rule. Okay, so that's why they say you either have three sides or two sides and an included angle. What they mean by included angle is the angles between those two sides. That's what this really means. Okay, so that's how I normally see it. If I look at a triangle and I say, oh yeah, two sides and an angle in between, I think of cosine straight away. If I see two corresponding pairs, side with an angle, I use sine rule. Sometimes it's not as clear, and sometimes you have to play around with the triangle to use a sine to become a cosine. You know, you play around with it. But for now, the exercise 13C, they're going to give you problems of this nature. Okay? All right. Now, the rule, which you're all waiting for, this is your rule. There's two types of rules because the cosine, nicely you can solve for the side length, which is the little a, or you can find the angle, big A. All right? And in both cases, you can still find the angle. In a sine rule, you can find the angle and side length. It's just, I think they just wanted to give you an angle formula. If it helps, just memorize the top. I always just memorize the top and then, so I only memorize this formula. I ignore this one. Reason being is because I can always rearrange the top equation to get the equation of the second one. So I don't bother memorizing this one, but if it helps you, memorize them all if you want. For me, sine rule is really easy because it was A over sine big A, little b over sine big B, and little c over sine big C. This is your sine rule. And that's always been easier to remember. And if I had to memorize two equations or two formulas for cosine rule, it just takes too long. Okay? I look at sine rule, and the way I I look at the cosine rule, and the way I remember it is it reminds me of Pythagoras' theorem. It's like c squared equals a squared plus b squared, so they're all different letters. So it's a squared equals b squared plus c squared. And if you've got a b and c on this side, then it's b times c. If you got the side A, then it's angle A that you're looking for. Okay, because the diagram that you're always drawing is whatever you're looking for, it's always occluded angle, and you're looking for that side length. That's why you're using cosine. So that's how I remember it. I say little a, big A. If there's a b and c, then it's b times c. So that means if I rearrange the equation, if I said c squared equals 2, good, a squared plus b squared, and it has to be 2ab cos c. Excellent. Okay. So all I'm doing is just rearranging the equation. C, the other two has to be a squared plus b squared, then that means it has to be ab. And then that means I'm going to find the cosine of the angle C. Okay, so that's how I remember. You find your own way of memorizing it, but Pythagoras' theorem, 2 letters are the same letters, times and cos the angle that you're looking for. Okay, so now you got your formulas. Let's have a look at proof. As always, I always like to talk about proof because what is the point of learning something that you don't know why it happens? Now it's the same thing as your sine rule, except this might be easier to sort of put your head around it. It's the same idea. Sine rule, we use the ratio of sine to opposite of a hypotenuse. Well, now cosine rule, you're going to use the ratio for adjacent of a hypotenuse. So what I'm going to say is, well, that means, let's talk about this triangle ADC. So that triangle, and I looked at this angle here, angle A. Then if this is my cosine, that's your adjacent opposite hypotenuse. Then cos of the angle, which is angle A, cos of the angle has to be adjacent of hypotenuse. And in our case, adjacent is x, hypotenuse is b. So I got my ratio. Okay, so cosine of my angle equals x over b. You can rearrange that and say times b on both sides, and you get b times cos of a is equivalent to x. That's the first step. Pretty straightforward, yeah? And then here's the nice thing. We're always going to use Pythagoras' theorem because in a non-right angled triangle, you want to split that up into right angled triangles because that's the only skill you learnt back in year 9. The only skill you learnt was to deal with right angled triangles. So Pythagoras' theorem comes in, and we're saying, let's have a look at these 2 different types of right angled triangles. So I've just highlighted one, ADC, and BDC. So BDC I'm going to color with a different color. This is BDC. So I got 2 right angled triangles right now. Okay, one on the right, one on the left. If you use Pythagoras' theorem, for the first one, it will be x squared plus h squared should equal to the hypotenuse squared. So I write that down. All right, yeah. X squared plus h squared equals b squared. Then same thing with this one. This would have to be, good, it will be c squared plus h squared equals a squared. So I write that down too. Okay, but remember this c is this whole entire length. So if you want just from d to b, it's c minus x all squared. Yeah, so if I just write out, just so you can see, this length here would be c minus x. If you want just from here to here, you got a and you got h. That's why it's c minus x squared plus h squared equals a squared. Then the nice thing is if you expand this side, you get this complicated expression, but here's a nice thing. See, x squared plus h squared, didn't you just figure out over here that x squared plus h squared is equivalent to b squared? So I can rewrite that. I'm like, all right, let's just call that b squared then. Okay, so that makes it easier. So we're looking very close to our cosine rule. We've got a squared equals b squared plus c squared minus 2. Now we've got to somehow change that x. And conveniently up here, we already said x is equal to b times cos of a. So if you put that all together, you suddenly got now 2bc cos of a, that's c squared plus b squared, which is the rule that you were memorizing before. Okay, and that's your cosine. So everything is just broken up into your Pythagoras using trigonometric ratios to sort of come up with these ideas to solve. Easy? All right, now let's do a couple of problems. Let's have a look at this one. Again, how do I know it's cosine? Notice the 2 sides. See, it's 5, 10, right next to each other, they're adjacent. And you've got an angle in between it. So immediately in your head, you should be like, cosine rule. Okay, so because it's a cosine rule, we've got an angle. So our angle is, in this case, it's C. So we've got angle C, which is 67 degrees. We've got a corresponding length, which we don't know. Little c, we don't know. So little c, I have no idea. I've been given 5. Now, what does 5 represent? Is that B, A, or what? What is it? A. Little a. It's corresponding, it's opposite to the angle A, so this is your little a. So little a is equal to 5. And then 10 represents what? Little b. Because it's opposite. It's opposite to the angle B. So now I've got B and A, and I'm looking for C. Now if this is my formula, all I'm really doing is I'm saying I want to find what C is. So it's C squared equals 2, and like I said, yeah, you got A squared plus B squared minus 2A times B cos of big C. And conveniently, I already got those. I got A, I got B, and I got big C. So plug it all in, and voila. Type in your calculator and you're done. Simple and easy. Okay, so it's all about identifying your points first, knowing which rule you use first to help you solve it. Remember the rule, and it's plug and play. Okay, it's a plug and play. So I've got your A is 5, B is 10, minus 2 times A times B, cos of 67 degrees. Make sure your mode is in degrees, or put that little symbol in if you're doing it with the mode radians. So it depends on your calculator settings. Just keep that in mind. That changes when you're in methods. So just really be careful, because when it comes to sacs for your methods, if you don't change that, you get all the wrong answers when you come to circular functions. It's not because you've done something wrong, it's just your calculator mode's wrong. Okay, and that's on you. The idea to have to know when you're in methods, change the modes so it's radians. When you're in specialists, change the modes to degrees. Okay, otherwise, make sure to add in the correct units and you'll be fine. Okay, radians and degrees. All right, here we go. Let's have a look at the next one. There's the last example. Pretty simple. Same concept. How do I know that this is a cosine rule again? You've got all three sides, and they're asking you to find the magnitude, which is how large or the size or the value of an angle. Angle ABC. So which angle am I looking for? B. It's always the middle letter tells me the angle I want. So I want angle B. And so, again, it goes back to my theory. If you've got two sides next to each other and an angle in between it, that's a cosine rule. Okay, so in my case, I've got 6, 12, and my angle. This is what I want to find out. Okay, now you can use your old rule. Okay, you can rearrange everything. You got little a is 12, little b is 15, little c also is 6. Okay, you don't have big A, you want big B, and you don't need big C. So you can use your formula and say, all right, well, I can rearrange it. If I want big B, remember you can have little b, which is b squared equals to a squared plus c squared minus 2 ac cos of big B. Okay? And now you can rearrange all this to get B, because you've got B, A, C, little a, little c, and you're trying to find big B. You can move it all across. So you can say minus a squared on both sides. So you got b squared minus a squared, and then minus c squared, and you got negative 2ac cos of b. So you know you can divide both sides by negative 2ac because that's multiplied. It's negative 2 times a times c times cos. So if you want to remove times, divide. So if you divide both sides by negative 2ac, this cancels out. And there's your formula to find b. Cos inverse of both sides, and b will equal to cos inverse of b squared minus a squared minus c squared divided by negative 2 times ac. Okay? Now that's up to you, whether you want to do it from where I'm showing you, because I do it from here because, to me, I just need to memorize one rule. Otherwise, if you don't like the whole rearrangement of your formulas, then by all means, use this formula. And I give it there for you. Okay, so that's your second formula to memorize. I personally don't think you need to. You can just rearrange it and still get it. Okay, but
is it using more time to rearrange it?
Well, over time you'll because when you type in your calculator, it becomes values. You can easily like calculate it without worrying. So it's up to you. If you like this one, memorize it. It's similar to it's similar to your how do you say it? It's similar to your Pythagoras' theorem, cosine rule. If it's big A, it's minus A. b squared plus c squared divided by 2bc. It's up to you if you want to memorize it. Okay, but if you do, that is the method. You type that in your calculator and you get that, and then cos inverse both sides. Make sure it's in degrees and they'll give you degrees. If you don't have that in degrees, it won't change it to degrees. Or if you get a radians, you can change radians to degrees on your calculator as well. So it's up to you. Okay? But if you make it in modes in degrees, then it'll just naturally give you that. Is that easy?
Yeah.
Yeah? All right. Here we go. Let's practice. And if you still have questions on your SAC, ask me. Let me try to clarify, like modulus, if that's still confusing. I can explain that in this session.
No, you don't.